everyone. So for today's lesson, we are continuing with measurement, and our objectives for today would be defining an arc and finding the length of an arc. So an arc is really part of a circle. So we're just going to run through some of the general definitions associated with a circle. Remember, you have the circumference, that's the distance around your circle. The diameter starts at one end of your circle circumference, passes through the circle center, ends at another point on the circle circumference. While you have the radius, which is half of your diameter, starts on the circle circumference, ends at the circle center. And we have the formulas for circumference. C is equal to 2 multiplied by pi multiplied by the length of your radius, or C is also equal to pi multiplied by diameter. You could use either one of these formulas for circumference. Pi, of course, as we saw in school, pi can be represented as 22/7 or 3.14. Now, let's get into our objectives, defining an arc and finding the length of an arc. So what's an arc? An arc is part of the circumference of a circle. So in both of these diagrams here, you're seeing pieces of circles. You're not seeing the entire circle, right? And in each diagram, the curved part here is actually a piece of the circle's circumference. And this is what we refer to as the arc. It's a piece of that circumference and it's a curved line. Now, in each diagram here, the arc, it's joined to a radius on either end. And you see in the circle center. Now, what's in every diagram like this, there's going to be an angle on the inside. And the general symbol we use to represent this angle is a Greek letter called theta. So the angle associated with an arc, we refer to that as theta. So let's look at the formula for finding the length of an arc. Here we have a diagram with an arc. Theta is the angle in the middle. Now remember, this arc, it's a fraction of your entire circumference. So what we want to do, we want to represent this diagram here as a fraction of the full circle. Now we know that theta is the angle in the middle. For a full circle, the angle in the middle will be 360 degrees. So as a fraction of a circle, this diagram here is theta all over 360 degrees. And this of course works for all arcs. And we're going to take that fraction of a circle and multiply by the full circumference to get the length of the arc. So the formula therefore is theta over 360 multiplied by a formula for circumference 2 by pi by r. So this will all make sense once we see an example. So here we have our example. We have our diagram with our arc, and theta in this case is 120 degrees. 7 centimeters is the radius. So length of the arc, the formula is given, theta all over 360 multiplied by 2 by pi by radius. We represent theta as 120 all over 360 by 2 by 22/7 for pi by 7, the length of our radius. The 7's cancel out. 120 could go into 360 3 times, and we're left with 1 by 2 by 22, 44, and 3 by 1 by 1 by 1, 3. We are left with 44/3 centimeters. This could also be